Okay, let's do cookies. Do you know cookies? What are cookies? What do cookies do? What? They taste good. That's not really an action. What do HTTP cookies do? Okay, yeah. You can be tracked by them. You can forget to clear them. You can have your your shopping cart stored in them, so that when you go from page to page, it remembers which things you've already put in it. Cookies are the basic way that web servers traditionally have had of sending like individual customized pieces of data to the client, not for the web browser to like display on the page as part of the web page itself, but to store locally, so that and then have the client send back to the server, so that the client knows things about the current state of the web browser, and maintain this consistency of the behavior, like over the course of clicking through a series of pages on, Amazon or whatever. Yeah.
So they sometimes deal with like authentication, like you don't have like that cookie or right cookie, if someone steals your cookie somehow, they can poses you.
Well, yeah. Like one of the things. So like what happens when you log into a website? You enter you enter your username and password, and you send it to the server, and they they recognize that you entered the right stuff, and so now they show you that they send you back a page that has your private content or whatever, and when you click on a button on that page to do something else, you don't have to log in a second time. Like once you've logged into the website, you stay logged in, for some amount of time at least. So you stay logged in as you click through each email to the next or whatever. You don't have to log in on every single page. And how come? Why doesn't it force you to log in again? Each time you click on a link, that's another HTTP request and response. In principle, it could be from a completely different like in principle, each individual HTTP message, it doesn't depend on anything having happened before that. Each individual HTTP message is caused by Each individual HTTP message is caused by somebody opening a socket to the server and writing some text into it. If you had to, if they didn't know who you were the first time, how do they know who you are the second time? And the answer is that in the page that they send you back, that the server sends you back in response to your login, they write a cookie in that page that has some like session ID or something, for example, name in it, and the value of it is some like mile-long string of hex characters that is a hash, a secure hash of you and your machine and the time of day, and it's some like relatively random unique code that they've generated based on the login that you just performed, and nobody else will have been able to independently generate that essentially random code in that instance. And so any web page, any HTTP request that they receive from your IP that has that code in it, they will trust that that is you again. That's the same person who logged in 10 seconds ago, now clicking on another link.
Press something and you open the link, you open the socket, you request, and you have to check it to make sure that you can access that content. And but it has to go through all of that process each time. Like you click something.
Well, so like each time you click on another link on Amazon, the HTTP request that your browser sends asking for that page, in the header of that request message is written the session ID that Amazon gave your browser when you logged in.
Oh, okay.
And you might say that look, it's coming from your IP address. They know the IP address of the person who just logged in. Why do they need the code? And like one example is if this is on your phone, as you're walking around on your phone, your phone connects to different cell towers and gets so it's accessing the network in different places. Its IP address can change in complicated ways over time. So like that, for example, would not be enough to securely recognize it. And like another like another thing that uses cookies is paywalls and leaky paywalls, so-called. So like the paywalls that on newspaper and magazine websites and things that give you like a certain number of stories for free, or a certain number of stories per day or per month or something, how do they know when you've read so many stories? So they see the IP address and the user agent info, and so of the machine that you're coming from. Actually, probably just the user agent info, because if you run out of stories, on the if you run out of free stories on the Times website, you can open up a different browser, right? Once Chrome runs out, you can open up Firefox, and once Firefox runs out, you can open up Edge. And once all of your browsers run out, you can clear the cookies. So like if they're like, what is their thought process when they say that you've read your 10 stories? Like the person in the apartment next to you, they can still read more stories. So like, what's the difference between you and that guy? Is it that they're on different Wi-Fi? Well, no, because like two people in Starbucks connected to Starbucks Wi-Fi, are both going to be allotted their same 10 stories by the Times website. Right? It's not based on the IP address. It's not based on what? It's not based on the MAC address of the of the hardware, which is probably unreadable by them. It's unique per the network card, but it's probably not readily visible to the Times website. It's not based on what? If you haven't logged in and created an account, which is why they're still limiting you to 10 stories or whatever. It's not based on like you actively telling them who you are. And like if you delete your computer, if you reinstall all your software again, they're presumably going to give you your 10 stories. So like at what point, like what does it take for them to fail to recognize that it's you again? So you mostly can. So most of these you can bypass by just going incognito. So like it always drove me crazy. These advertisements about free Times access for students and whatnot. Instead of having these marketing campaigns about how you can log in with your special school address and get free access, they could have just like mailed everybody a keyboard with a shift key on it. So like if for anybody who has a keyboard with a shift key, when opening the Times website, they can open it in an incognito window, and then they won't need to remember what their school email address was and enter it and click on the authentication email. They get sent to that email and et cetera, et cetera. So it's like not completely all, but mostly all. The vast majority of these leaky firewall, leaky paywalls. Like the only thing that is like blocking it is the what's written about you in the cookie for that website on that particular browser that you're using. There are a few exceptions to this. The Washington Post paywall is like very serious and is much tougher. They like a couple of years ago, they started like going to war against incognito. They would do these funny tricks to try to detect when you were in incognito mode and when you weren't. And like in theory, it should be impossible to do that. Like in theory, incognito mode could just be like tantamount to a new browser that has just been installed on your computer. And as long as the incognito mode window is open, it's writing cookies, in this, special directory or whatever for the pages it's viewing right now. And when you close that window, then those will all be deleted. But during the time when that incognito window is open, it should be behaving exactly like an ordinary browser would. But like the security engineers at the Washington Post, were doing some kinds of complicated things to try to detect them. But by and large, it's mostly.
It's just like the browser window with no information like history.
Yeah, it's basically a window that whenever you close it, it automatically does clear all cookies, clear all saved content.
Okay.
Like I don't know if Chrome still does this, but it would say that it's not protecting you from people who are standing behind your back, looking over your shoulder. It's not doing like security of like HTTPS style security like during the communication itself, it's just purely on your end. It's just purely for the people who will be examining, your particular machine, after the fact, to see what you've done. So let's code up some cookies. So cookies, you set them in the header. The field is set cookie, and you write it like this. So this thing is the value of this particular header entry, and the value of this takes the form of name equals some other value. So the cookie SID is being set to this random string that I typed. And I missed the plus. Thank you. Slide that one down. So Here, the cookie is written, as you can see, fine. Mm. Right. Let me see if I can. What would be the quickest way? Um, So I'm running out of time on Zoom and in IRL. So I wanted to I wanted to code up a baby example of cookie being set and reacted to, but um, somehow typing with my head turned is making that too difficult. So let's actually end here and next time, so I'll rather than trying to do it all live, I'll code up most of it in response to before. So before we go, any questions on the homework on the program? Okay, so I'll post the my server program that returns the chunked string from the Wikipedia that I was writing earlier. The third one for you to test on using your program. Okay, so sorry about the technical difficulties. Have a good weekend. See you next week. Sure. Or just one second.